Today's video I would like to introduce a very nice problem of Croatian Mathematical Olympiad edition 1997 4th grade. Okay, here is the following setup. Find the last 4 digits of this number. Okay, 3 to the 1997. This 1997 is representing the year of this problem. So anyway, this is very nice problem, but it's little challenged. Okay, so in order to solve this one, is arithmetically going to apply the Euler Theorem. Okay, this is the best method to solve this one. It's helping us a lot to reduce this exponent. Okay, we have the GCD of a as a base. We have GCD of the base a and n equals 1. Okay, in our example we have a is replaced with number 3 and exponent n is replaced with 1997. Okay, so this one implies a to the phi of n is a congruent to 1 mod n. Okay, according to the Euler Theorem. I would recommend to give a try to this problem prior to get into the solution. So by the way, don't forget to support us with your like and subscribe. So let's jump into the solution. So this is the general formula for the Euler Theorem. We have phi of n equals n is multiplied by 1 minus the reciprocal of p1 and all the way down to the pk. p1 through pk are factorization prime. I'm going to reduce this one to mod 100 by using this tension function. Okay, simple. Before I proceed, I have to make sure we are allowed to use this formula. We check the GCD first. GCD of 3 and 100 equals 1. Now is allowed to apply this theorem. We have to have GCD of the base and n must be equals to 1. Okay, I'm going to determine the factorization prime for 100. We have only 2 prime factorization for 100. We have number 2 and number 5 are the primes, because 100 divides by 2 is giving us 50 and 100 divides by 5 is giving us 20. Okay, so it's very clear here. Phi of n, phi of 100 equal 100 is multiplied by 1 minus 1 over 2 factor 1 minus 1 over 5. Okay, if we calculate this one is giving us 40. I'm going to reduce this one to mod 100. So I will have 3 to phi of n. I'm going to replace phi of 100 with its value. We'll have 3 to the 40, so congruent to 1 mod 100 according to the Euler Theorem. Okay, now I'm going to work on this one now. Let's launch in our example. We have 3 to the 1997 equals 3. I can write 1997 as 2000 minus 3. Okay, 2000 will be written on the form of 3 40 multiplied by 50 minus number 3, which equals 3. By reading this one to the n exponent, I will have 3 to the 40 to the 50 is multiplied by 3 to the minus 3. This one, it's very clear, it will be replaced with number 1 because I'm going to reduce this one to mod 100. So we'll have 3 to the minus 3 mod 100. This one goes to 1 because it is reduced to the 100 according to the Euler Theorem. Now we need to calculate this one. Now the only thing that we are going to calculate this one. Now we have 3 to 1997 is a congruent to 3 minus 3 mod 100. Are going to calculate the inverse 3 to the minus 3, the inverse. Okay, we have number 1 is a congruent to 1 is a congruent. I'm going to replace with 1. This one is 3 is multiplied by 67. Okay, this value equals to this value mod 100, because if you take number 1 to the right, I will have 200. That's mean 100 divides 200. Okay, this is correct. I'm going to raise number 3 as a power on both sides. I will get 1 to the 3, which is congruent to 1 is a congruent to 3 to 67 to the 3. Okay, I can rewrite like this, mod 100. I'm going to take the inverse of this one. So the inverse, now we'll have inverse by taking 1 over 3 to the 3, which is 3 to the minus 3, is a congruent to 67 cubed mod 100. Now I have ended with this expression. Now I'm going to calculate 67 to the 3. Okay. So now I'm going to calculate 67 to the 3. Okay. If you calculate this term, 67 cubed is the same as 300,763. This is same as 3 to the 3 is multiplied by 10 to the 5th plus 763. Okay, as a remainder. If I'm going to reduce this one to mod 100, so as we have before, this one is term is called 3 to the 2000 minus 3. It was 3 2000, 3 to the 2000 is multiplied by 3 to the minus 3. We have shown this one, it was 1 mod 100, because this one, it was reduced to 1 mod 100. Then I will be left only with this one, 3 to the minus 3, which is this one, is a congruent to 67 to the cubed, which reduces to this one. Okay, this one, if I'm going to reduce this one to 100, this one goes to 0, because 100 is divided this one. So I will be left with this remainder. So if I'm going to reduce it to 100, so I will have 763 as a remainder, but I need 4 last digits. So that's mean I'm going to take these 4 digits. Okay, so it is a congruent to 763 mod 100. Since they need 4 last digits, so I'm going to take include 0 here in the front. So I will have a 4 last digit, which is 0763. Okay, so we found the 4 last digits of this number. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.